we have seen how do we get RMS value of the voltage when they or the current when they are expressed as a function of a Fourier series functions. And now, if you look at this particular voltage, which is expressed in terms of a Fourier series, the RMS value of this voltage is V RMS is equal to square root of V naught square plus you have V1, V2 and so on. There are infinite number of terms where you will write down that as V1 maximum value by root 2 whole square plus and so on. If you have n number of terms, Vn max by root 2 whole square. So that's how we get RMS value of the voltage. And if you have a current, then we also know similarly we can get the RMS value of current from the Fourier series. Now, as we see that voltages and currents, how do we get the real power that corresponds to this voltage and current? In order to get the real power is nothing but the average power or average of the voltage and current product. Now, if you're trying to look at that, we can say that the real power, that is P average, which is nothing but the average of this voltage and current product. Now, if you substitute that voltage and current here, which are expressed in terms of Fourier series, then we have the average of, that is 1 upon t, integral defines the average of that particular function for us, voltage as well as the current. Now, when we try to simplify this particular integral of Vi, what actually happens, we will be having 4 different terms. The first term is integral of this voltage and this current constant. Now, voltage and current constant terms integral will remain there. But if you look at the voltage multiplied with this current functions, then this voltage multiplied with the cos functions of the current will be a cos function. And now, if that cos function average you want, it is just a cos function which is multiplied with the voltage value. The scaled cos function will have an average value as 0 itself. So the voltage multiplied by the sinusoidal current terms will remain 0 in terms of average value. Again, this voltage multiplied by the constant value of the current, the resultant of these two product will have an average value as 0, so this also will be neglected. So we have only the voltage and this voltage constant value, and at the end you will have this voltage and this voltage, the sinusoidal value. So now you can see that my average value of the power will be nothing but the voltage multiplied by current. The DC value average will remain same as the DC value. And now this sinusoidal value of the voltage and sinusoidal values of the current, when you find the product of that, then you will have this particular expression for the average value of the current. Now, the voltage and current product, when you look at this, we don't have the voltage of one frequency multiplied with the current of a different frequency. Now, you can see that this is a sum of, let's say, n number of terms, and this is sum of n number of terms. Instead of getting that product of all the terms, we have only n number of terms here. The reason for that is this voltages of, let's say, n equal to 1, when they are multiplied with the currents of n equal to 2, then the voltage and current, which are sinusoidal functions of the different frequencies, the product of the sinusoidal functions of different frequencies, if you get the average of that, that itself will become 0. So because of that reason, we have only n number of terms here. So this is what is an expression for the average power that we get when you have voltage and current expressed in terms of a Fourier series. Now, let's say you have a voltage and current. Both are expressed in terms of Fourier series. How do we get the power that corresponds to this voltage and current? Now, let's get the RMS value of the voltage if you wanted to get. Then we know the way to get RMS value of the voltage. That's where we get RMS value of the DC, RMS value of the first order frequency, RMS value of the second harmonic. Now we use that and get the resultant value of the RMS voltage. Now similarly, if you want RMS value of the current, then get the RMS of 2.65 cos omega naught t and 2.43 cos 2 omega naught t. Then substitute in the similar expression as the voltage we have, then we'll be getting current RMS value. Now after getting the RMS value of the current, if at all you wanted to get the power, we know that the power is V0 I0. V0 I0 is how much for us? 10 multiplied by 2. So 10 multiplied by 2 is V0 I0 for us. And after that, you just multiply the RMS value of voltage 1, current 1. V1 RMS, I1 RMS, V2 RMS, I2 RMS, V3 RMS, I3 RMS, and multiply that with the respective power factor. Now, if you look at that V1 RMS and I1 RMS, 20 by root 2 is going to be RMS of this, and 2.65 by root 2 is going to be RMS of the second one. So voltage and current. And then the power factor, cos of the phase angle difference, minus 25 minus 75 is going to minus 25 plus 73. We'll have that power here. And again, we have the next voltage and current expressions. Now, the voltage RMS is 30 by root 2, and current RMS is 2.43 by root 2, and the power factor of that we get it as a phase angle difference between these two, then substitute that. So V0 I0, V1 RMS, I1 RMS multiplied by the power factor, V2 RMS, I2 RMS multiplied by the power factor will give us the average value of the power. We can simplify and calculate that average power here.